In this video we're going to look at alkenes. Before we get onto that, I just want to talk to you about a couple of reaction types. Dehydration and condensation can be easy to get mixed up. Dehydration is when you have a single molecule and water is lost from it, whereas condensation is when molecules join together to make a bigger molecule, along with the removal of a small molecule, such as water. Make sure that you make a note of what dehydration is. Another word that we sometimes come across in textbooks and past papers is reagent. A reagent is basically any chemical that can be used to synthesize another chemical or sometimes used for chemical analysis. We'll be looking at examples of reagents in this video. First of all, we're going to look at how we prepare alkenes, and there are two ways you need to know about. So in the lab, you could start off with an alcohol, such as ethanol. You could add concentrated sulfuric acid, heat it up, and you can see that water is removed to produce the corresponding alkene ethene. So have a think about what type of reaction this is. It is dehydration. We are removing water from one molecule. The reagents for this are concentrated sulfuric acid, but you also need to know about two other reagents, concentrated phosphoric acid or hot aluminium oxide. If you see an alcohol being treated with any of these, what is happening is dehydration. These are all dehydrating agents. In the case of hot aluminium oxide, what happens is the alcohol is vaporised and it's passed over heated aluminium oxide and the dehydration occurs. Now, there are two possible products for the dehydration of this alcohol, and you can see that when it gets dehydrated, the OH is going to be removed from that carbon, and to make water you need another hydrogen. So the hydrogen could be removed from this carbon here. And if that happens, you get but-1-ene. So you get the double bond forming on carbons 1 and 2. Alternatively, the OH could still be removed from the second carbon, but the hydrogen could be removed from this third carbon. And in that case, you're going to get but-2-ene. So the double bond forms between carbons 2 and 3. The second way in the lab to prepare alkenes is by starting with a molecule called a haloalkane. That molecule you can see on the left is called iodoethane. We're going to learn more about haloalkanes later on, but they are basically an alkane in which one or more of its hydrogens has been replaced by a halogen. So the halogens, remember, are group 7, fluorine, chlorine, bromine, iodine. So this haloalkane is treated with potassium hydroxide, KOH, but you'll note that it says alcoholic potassium hydroxide. So that is potassium hydroxide that is made up in ethanol as opposed to water. And you can see what happens. The iodine atom is removed from one of the carbons, and a hydrogen atom is removed from the carbon next door, and you make the corresponding alkene. So that this type of reaction is a new type, and it's known as elimination. We'll learn more about elimination later on, but elimination is when you remove a small molecule from a molecule to create a multiple bond. in this case a double bond. Reagents, well, the reagent here is our alcoholic potassium hydroxide. So we need a strong base that's dissolved in ethanol. Once again, there is a possibility of two different products which would be isomers of each other. So I'm going to draw those on. So you could remove the bromine from here, well, it has to be removed from there, and you could remove a hydrogen from this carbon, and you would get the double bond forming between the first two carbons. Or you could get the hydrogen being removed from this carbon instead, so you would get the double bond forming in between the middle two carbons. So you could again make but1ene and but2ene. Just change that. Now we're going to move on to the bulk of this section, which is all about the reactions of alkenes. Alkenes undergo electrophilic addition reactions. So we'll break that down. Addition is when you add a molecule across a multiple bond to make one new product. And an electrophile, you should know from previous work, is something that is wanting electrons. So they are chemical species which accept pairs of electrons. They're attracted to electron-rich parts of molecules. And we often say that electrophile will attack electron-rich parts of molecules. And what that means is it will accept pairs of electrons from it. Because of that, we call the reactions of alkenes electrophilic addition. It's an electrophile that attacks the electron-rich double bond. So we're going to look at some examples of electrophilic addition. There are 4 examples. First of all, this is one we've come across before. It's adding hydrogen across the double bond to make the corresponding alkane. So this is electrophilic addition, but we can also call it hydrogenation because we're adding hydrogen. In terms of reagents, the only one is a nickel catalyst. So it's not reacting, but it is needed for the reaction to happen. You do not need to know any more details about this reaction. The second reaction you need to know about is the addition of halogens, or the electrophilic addition of halogens. So halogens, group 7. So we could have bromine, chlorine, fluorine, iodine. This example, we have bromine adding across the double bond of ethene to make 1,2-dibromoethene. Now that should say ethane. So I'll just change that. 1,2-dibromoethane. It's ethane because it only has carbon to carbon single bond. Now, the reaction type is still electrophilic addition, but it also can be called halogenation. Sometimes it's called bromination if it's bromine. Reagents, don't need any reagents. If you think about it, if you add bromine water to an alkene, it decolorises the alkene immediately. So there's nothing else needed for that reaction to happen. You might be saying to yourself, well, where's the electrophile? Well, we're going to look at that later on when we look at reaction mechanisms. So you need to learn the reaction mechanism for this type of reaction, and we're going to look at that a little bit later. The third electrophilic addition reaction is adding hydrogen halides. So by that we mean, for example, hydrogen bromide, hydrogen iodide, hydrogen fluoride, hydrogen chloride. So you can see again, it adds across the double bond with the halogen going on one of the carbons involved in double bond, the hydrogen going on the other. So again, it's electrophilic addition. We will look at the mechanism for this later and find out what the electrophile is. Reagents, well, there aren't any. It happens readily, this reaction. The last reaction type you need to know is the acid catalyzed addition of water. So, if you see an alkene and you are adding water to it, then we can call that electrophilic addition because the water adds across the double bond. You can also, of course, call it hydration because you're adding water to a single molecule. If I draw water, so the water will break one of the covalent bonds, so let's say it breaks here. So we can see that a hydrogen will go on one of the carbons and the OH will go on the other. You do need a reagent. The reagent is the acid catalyst. Sometimes it's written just as H+, sometimes it's written H plus AQ, sometimes you might see it like that, H2O / H plus AQ. So whenever you see this, it's an acid catalyzed reaction. We will find out why we need the acid catalyst when we look at the mechanism for this reaction. Now, sometimes when we do addition reactions, depending on what it is we're reacting, you can get a mixture of products, and you get a mixture in which one of the products dominates. And how we work out which product we get the most of is by using Markovnikov's rule. So here we have but-1ene, and we are going to add hydrogen bromide across the double bond. So we're going to add an atom here and an atom here. Now, which one goes in which carbon is determined by the rule. So here's the rule. So the hydrogen atom of the HX molecule, X being a halogen, or of the HOH, remember that's just water, attaches onto the carbon of the double bond which is already attached to the greater number of hydrogen atoms. So we can see that that is that one there. Carbon number 1 is already attached to 2 hydrogens. Carbon number 2 is only attached to 1 hydrogen. So the H will go on carbon 1 and the Br will go into carbon 2. So this will be the major product. When this reaction happens, most of the but-1ene undergoes a reaction as shown, and we get this product which we would call 2-bromobutane. Some of the molecules, some of the but-1ene will undergo the reaction where the hydrogen joins to carbon number 2 and you will get 1-bromobutane. So you will obtain a mixture of products, but this one there will be the most of. We'll find out why that is later on. So this applies when we add water across the double bond. Remember, water is going to break up into H and OH. And if we follow Markovnikov's rule, again, the hydrogen, I'll have a think about which carbon the hydrogen is going to go on. So it's going to go on to the hydrogen which has got the greatest number of hydrogens already. So we would predict that it's going to go onto carbon number 1, and the OH is going to go onto carbon number 2. I've put that there because remember this is acid catalysed. And indeed the major product is propan-2-ol, and you've got a minor product propan-1-ol. The last part of the alkenes is looking at mechanisms for the addition. Now you need to know 3 mechanisms